each day before the CCA, or each part before the CCA, one of the 2 days, I'll spend some time up here just talking about what it takes to get ready for the CCA. And we have 2 days of this. We have Tuesday and Thursday. And this package covers similar triangles, but it also covers trig. We probably should do similar triangles then trig. I'm not going to because your trig test is tomorrow. The way we've organized things, you're like, don't tell me about similar triangles today. Tell me about trig today. So we're going to skip ahead in your package a little bit and do that. I do want to write down the date of your CCA, which might change year per year. So if you're watching this video in a different year, you should definitely check with your teacher to make sure of what day your CCA is. Our CCA day 1 is Friday, June 7th. Which isn't supposed to be that scary because we're doing similar triangles and trig, which is the stuff we were just working on. So in theory, that shouldn't scare you too much. And like I said, on Thursday, I'm going to come out and finish this video, and I'm going to come and do the similar triangles version of this, and hand back your similar triangles assignment at the same time. So that'll be similar triangles today. So skip ahead, and we will do trig day. Yes, do you find the spot where it says Unit 8 Trigonometry? Okay. And let's just talk trig for a minute. And this might help when you go do your review, now that you're re-motivated by my wonderful speech. Yes? There's a basic decision that has to be made in trig. What kind of triangle is it? And these are right triangles. And you can tell because they've got those little right-angled symbols in them. This says solve for side lengths in right triangles. That is an error on this note, that it doesn't have a right-angle triangle. I noticed it this morning, but I left it in because I wanted to talk about that it's got to have that right-angle symbol. Just because it looks like a right angle, no, it's got to have that symbol on there. So when you're going to do these, that's the symbol you get. Now, who wants to list the potential weapons? Let me just think. 1, 2, 3. We have 3 potential weapons to use when the triangle's right angled. Sakatoa, that's the new one we learned this year. It's interesting that she said that one first, isn't it? Because it's the last one you learned. You had 2 before you came to my class. What were the 2 you had? Pythagorean theorem, SATT. So you know all this stuff. In right angle triangles, those are the 3 weapons you have. So it says solve for the side length, solve for side x. If I'm solving for side x, I'm not using sum of the angles of a triangle. I can get that other angle, but it doesn't ask for that. So is it Sakatoa or is it Pythagorean theorem? It's Sakatoa. How come Pythagorean theorem won't work here? Yeah, you need 2 sides. That's simple. You need 2 sides to use Pythagorean theorem. Up until this grade, we always gave you those 2 sides. We found out this year you don't have to do that. Okay, here's the steps in Sakatoa. They're always the same setup. Circle the angle that you're going to use in the question. Not the 90, one of the other angles. Label the sides based on that angle. What's the 18 called? Hypotenuse, because it's the long side. What's the x called? Opposite. And we'll label the third side, even though in this question you wouldn't have to label the third side because we're not going to use it. What's that third side called? Adjacent. I heard some people say it. Adjacent. And then you need to know the fancy word. What is the fancy word? You're saying it like me. As long as you can spell it, it doesn't matter how you say it. But technically, Sakatoa. I don't know why I say Sakatoa. Maybe because I know it so well, I don't even care. I know these things. So which one am I going to use if I got hypotenuse and I want opposite? Sine. So I write down sine of 37 equals opposite over hypotenuse. Some of you are skipping that step. You're jumping right to here. I'm not saying that's good or bad. I'm just acknowledging it, that some people get so good at these that they just immediately write down the actual line of math they need, which is sine of 37 equals x over 18. Now, you can type in sine 37 at that stage and get that to a bunch of decimal places, and then just multiply it by 18. That totally works. I taught it slightly different. In preparation for sine law, I said, put this over 1 and cross multiply. See how that trick transcended Sakatoa. It was a good trick for sine law as well. And so I get x equals 18 sine 37, and your calculator does the rest. Make sure you're in degree mode, and then I've already forgotten what it said, so I'll move that over there. I'll move that over there. 18 sine 37. But now is the time. If that causes you a problem, if any step of that is difficult, now's the time when we're talking about this right now to talk about how to handle Sakatoa. Do you have questions? Incidentally, the put it over 1 and cross multiply thing totally takes care of the what happens if the unknown's in the denominator. My version of cross multiplying it doesn't care that the unknown's in the denominator. It's just one extra step in the whole thing. All right, this time it says solve for theta. Does anyone know before we even start how this is going to be different? What is going to be way different when you're finding angles? You're going to have to do it using inverses. So that's the big hint going in, is that if you're finding angles, we're going to have to undo sine and undo sine or cos or tan or whatever it is. So then same steps basically. You label these sides. The long one across the right angle is the hypotenuse. So what's the one beside theta called? Adjacent. That is what adjacent means. If you look it up in the dictionary, adjacent means beside. Yes? So I've got adjacent and a hypotenuse. Which of these Sakatoa things am I using? So then it's cosine of theta equals adjacent over, oh, I'm going to write it as adjacent over hypotenuse. I know some of you like to write this, which I like too. I love that version of it, to write it like that. Now, for someone who is confused at this moment, it's like, Mr. Todd, my calculator doesn't have a theta button. It's actually a pretty good question, because it looks like you got to hit cos theta, but you don't. You got to do something different. Yeah, use the shift button. Somebody hit cos theta, if you want, and they got 5 over 11. So I got to find out what angle did they use. So then I go, theta is the cos inverse of 5 over 11, which means undo cosine. Find out what the angle was that produced this 5 over 11. So you got to hit the shift cos, and then 5 divided by 11. And I get 62.96, which even rounded to the nearest degree is still 63.0 degrees. Any questions about right angle triangles? That's not the end of the story, by the way. Right angle triangles could have SATT. They could have Pythagorean theorem. But that's the new stuff. That's the stuff that you really want in your CCA prep package to remind yourself the steps. If you had to flip through. We don't want to have to flip through during the open book test. That's when you know trouble might be starting in an open book test, when you're going flip, 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 flip. But if you just wanted to, you did an angle and you just wanted to check to make sure, I got this set up right, this can help you, yes? Formulas, all the formulas will be on all the parts, yes? So, for non-right angle triangles, and look, it's labeled right there on your CCA package. Sine law. When do I use sine law? When it's not right angled. Solve for an unknown angle. You may want to put the angles in the top. Good cross multiply, people are like, I don't care which version, like it's the same either way. When do you use sine law? When you have one complete ratio and one other ratio with only one unknown. What do we mean by that is we're looking for one side or angle and we've got a matching pair. Okay, now this says find all the sides and angles. My question right off the hop is, will sine law work? Yeah, 16 and 36 are directly across from each other. I've got a BB. So look here, B. I'm going to call that little b, call that little a, and I'll call that little c, but me, I always do that. I always make that angle a giant C. Do you see how we've got both B and B? As soon as you got both B and B, sine law goes, I can help. Which side or angle can I go after here? I can only go after A, because I don't have any of the C's at this point. That's scary, right? But we talked about problem solving. Sometimes you're like, okay, I'll jump off that bridge when I get to it. For now, I know I can find A. Let's get that done and see where I'm at. So sine A over A. I did as the notes say, and I put the unknown in the numerator, equals sine B over B. And you just fill in the things you know, which is sine A over 23 equals sine 36 over 16. I'm going to do the full cross multiply thing. Those of you who are a little better at this might notice that you don't need to cross multiply here. You just got to bring the 23 over. But I'll do the whole steps. I go 16 sine A equals 23 sine 36, which again, you could get 23 sine 36 as a decimal and then divide if you wanted. That is totally fine. I like solving for it first and getting it all as one big piece that I can put in your calculator. But if you don't, go ahead. As soon as you've got 23 sine 36, type that in, get the decimals, write them all out. I don't like writing out all those decimals. So I wait until I've got it rearranged to do it. And so what I get is 23 sine 36, and divide that whole thing by 16. And then I'll need someone who's right with me to explain why this answer looks so completely weird. 0.844. The angle's 0.844? There's no way that the angle should be 0.844. What did I miss? Sine inverse. So if you're looking for an angle, at some point you're going to have to sine inverse that thing. So I've actually got to do sine inverse of 23 sine 36 over 16. And if you do that mistake on your calculator, not mistake, if you miss that step in your calculator's ready for that. You can go second function sine and then just hit the answer button on your calculator. Pretty handy little button, the answer button. And I get A equals 58 degrees. I'll just fit that in down here. 58 degrees. Most of the questions will ask for the angle to the nearest degree. Now look what I did. I jumped ahead there on you. As soon as I got the answer, I put it up in the triangle. Very helpful move. Why is that so helpful now? No, you have a different question? Question. 57.6. You could totally write 57 well, you should probably write 57.7. I'm just prepping you for the idea that most tests, most culminatings will ask you just to do it to the nearest degree. If you do it more accurate than that, it's not wrong, but they give you permission. And the reason is degrees are really small. Right, yes. So you have to read it carefully and check, or ask me. I don't mean to ever catch you confused about what you should round to. If the question doesn't say, you can ask me and I'll tell you what I'm looking for rounding-wise. Okay, why is that, writing it up there, such a good move? It should trigger something. Josh. Yeah. See, you don't really need a whole bunch of problem-solving steps because you're like, oh, now I know what to do. Now I can go after C. C is 180. Subtract 58. Subtract 36. And I'll punch it in my calculator. Subtract 58. Subtract 36. And I get 86 degrees, which I will also write on my diagram. I like drawing a line across there going, there, done that part of it. Now what? Now we can solve for C because I've got one of the C's. So I'm going to use C over sine C equals B over sine B this time. Slightly different. Now, because I'm going after side C, I'm going to show the other way. I'm going to show without the cross multiplying, so you can choose which way you like to do it better. So C over sine 86 equals 16 over sine 36. And if you really can see what's happening here, because the unknown's in the numerator, I don't need to cross multiply. What I really need to do is just take the sine 86 and move it over and multiply. So that's a little half step. I don't say that that's just life-changing. I just mention it just in case people are doing it like that. I'm giving them full permission to go ahead and use that instead of cross multiply there. But again, if you're like, no, I'm totally good with cross multiplying, thank you very much, I'm doing very well, I will just continue to cross multiply, then I think you should. There's no real problem with that moving forward. It's not some kind of thing where later I'm going to be like, oh, because you cross multiplied, that's a problem. Did you type it in? Did you get the same as me? I got 27.15. Normally side lengths will be 1 decimal place. So that's 27.2 centimeters. Any questions about that? That's one that can be totally done with sine law. And some questions, sine law, will get you all the way through. We did a whole bunch of homework where sine law was, well, I don't know if we did a whole bunch of homework. I assigned a bunch of homework where sine law was all you needed. You just sine lawed everything and bang, Bob's your uncle. I pause for questions though, don't wait around. If you want to know about this, you got a test Wednesday, CCA Friday. Is it okay? It actually does work on a right angle triangle. So if you mistakenly use sine law on a right angle triangle, it actually does work. So when it says for non-right angle triangles, that's not actually true. But we do encourage you to use SOHCAHTOA because it works much better. And especially when you go take courses like physics and so on, the math is going to come out more tidy if you use the SOHCAHTOA for right angle triangles. Okay? Cosine law. It looks very messy. And I think I convinced some people that it's actually a little easier to use. It's just plug in. It's a lot of plugging in, but it's just plugging in to use cosine law. When do we use cosine law? Who can answer that? Yeah. There's a lot of complicated ways to say that, actually, but it all comes down to as simple as if I don't have a matched pair to use sine law, I'm going to have to try to use cosine law. We've got these ones up here at the top, we're finding sides, and these ones down here, we're finding angles. What a good reference sheet. Yeah? Here. Instead of flipping through everything on CCA day, this is pretty good. This may be where you start your flipping. I hope you don't have to flip it all through your book. But if you do, this is a good place to start because it's all there in one spot. Solve the triangle. Solve the triangle means find everything. Friends, on the CCA, please remember, when it says solve the triangle, don't go after one thing. Get everything. Yes? You can actually ask me to clarify that. You can call me over and say, Mr. Todd, what am I going after here? And I'll just go, solve. And solve means get everything. But let's pretend this question just showed up, not in the cosine law part. Like it's like right underneath cosine law in your package. It's like, I think it's cosine law. But it's not going to necessarily show up like that in the CCA. It's going to be some random triangle. Why is this question not a good one for sine law?
No side angle pair, it's not right.
Beautiful answer. He said it in two parts. Both were just as important. He said no side angle pair. 52 degrees, I didn't have the side across here. 17, I didn't have the angle across there. And 28, I didn't have B over there. And no way to get it either. There's the odd question where you can just use some of the angles of a triangle and get the other angle. And he said it's not right angled. So SOHCAHTOA is out. So it's got to be cosine law. Which side can I go after if I've been given angle C? You shouldn't know that on the top of your head necessarily, but look at the formulas. If I've got angle C, which side can I get? C. Take a look. The formula with angle C also has side C. So if you've got angle C, you're going after side C. And then you can transpose the formula over. I've got it memorized. Who has it memorized? Who wants to take a shot at it? C squared equals A squared plus B squared. If you're that far, you're well on your way to knowing cosine law. And then what's the last part? Minus 2ABs. And then cos of big C. And yes, see, I'm following through what I said. I put big, when I do C's that are the angle, I do big C. And you might disagree with me at that moment. It's like, look at all that stuff. But it's just filling them in. Once you've made the decision that you're using cosine law, the rest will be fill in. So C squared equals, ooh, which one's A? This is the A, and this is the B. even though it won't matter. I'll get the same answer if I reverse A and B, actually, in this particular case. But let's stick to the formula. Let's do what the formula is saying. 17 squared plus 28 squared minus 2, 17, 18, cosine 52 degrees. And here's why I like cosine law. Cos what? Oh, yes. Sorry, it's not an 18 there. Nice catch. I got to go back here. Get my eraser out and put 28 there. And me personally, and everybody's different, I'm not trying to convince you. I'm just trying to tell you that some people like cosine law. Like, it's a lot of subbing, but I got to cross multiply, I don't got to move stuff around, nothing. Just type it all in. 17 squared plus 28 squared minus 2 times 17 times 28 times cosine 52 equals, what? 486. 0.89. I hear discussions going on that are the right discussions. But just in case you're not sure what's going on, don't panic. When this happens, that's ridiculous. There's no way there's a triangle that has 17, 28, and 486. What's left? Square root, because this is solving for c squared. So then I got to square root that big thing. Which I'm just going to use that answer button again. And I get 22.1. Again, if the question said 1 decimal places. Yes? Which it usually will. And fill that in on your diagram. Ooh, I wrote centimeters. Now what? Got to find another angle. Yes, going to have to go another angle. And I restart the clock. I go back and go, is it right angled? No, it wasn't right angled before. It's not right angled now. Could happen. Maybe I solve for something and I find out it's right angled. Maybe I can switch over to Sakato. Now, someone just said, now we can use sine law. Usually after cosine law does one thing, you can sine law the rest of the way. Yes, because you're like, okay, now I do have a matched angle pair. Angle side pair. So I'm going to go after, it doesn't matter, I'm going to go after B. Actually, I'm lying. I'm going to go after A. Sine A over A equals sine C over C. Fill it in. Sine A over 17 equals sine 52 over 22.1. And this time I'll show the cross multiply again. Just in case that's where you're at with this, is cross multiplying 22.1 sine A equals 17 sine 52. Sine A equals 17 sine 52 over 22.1. And I'll show it another way here again. You could type that all in and get a decimal that won't make any sense. Or you could keep rearranging and finish this off and go, I'm going to sine inverse this whole disaster. But you don't have to do it that way. If that's confusing, just go ahead, get like I did in the previous example, punch that in and you'll get 0.8642, whatever this mess is. And then you can sine inverse it after, if that makes more sense to you. But I want you to have both ways in your notes. 17 sine 52 over 22.1. Anyone else type it in? Did you get 37 degrees? I know it's 0.3. And if you use a decimal place, that's no problem. Most tests and culminatings will say round to the nearest whole degree. Oh, I ran out of room here. Is it going to be enough space? Yeah, because all that's left, and it's often true, is just SATT. SATT, it's usually last or it's first. That's the two places you usually see SATT fill in. B is 180, subtract 52, subtract 37, which again is very close to 90, I think. Just the way this one worked out, but not right on 90. And if you're wondering, well, if it was close to 90, would SOHCAHTOA have worked here if I had used it? Well, it would have been close. It would have given okay answers, but it wouldn't have given the right answers. Okay? Any questions about cosine law? Hopefully that's a jumping off point to get more of your review done. Stop messing around. Is your question about this or something else? All right. Let me just finish end the video.